Welcome back to KrossUSA channel. From water wheels to diesel power, witness the craftsmanship that built America. Today we're taking you inside 3 remarkable sawmills, where century-old techniques still produce quality lumber the old-fashioned way. Let's step back in time. There's something almost magical about watching a century-old sawmill spring to life, its massive blade singing through logs just as it did when Teddy Roosevelt was president. Today, we're taking you to the Auto, Tractor, and Engine Show in Lathrop, Missouri, where history isn't just preserved, it's still working hard, demonstrating the ingenious engineering that built America's lumber industry. And at the heart of this living museum piece stands a magnificent Reeves 13-horsepower engine paired with a 1903 Port Huron sawmill. Now, if you're wondering what makes this combination so special, let me paint you a picture of early 20th century American ingenuity. The Reeves Company, founded in Columbus, Indiana, was renowned for producing reliable steam and gas engines that powered everything from threshing machines to sawmills across rural America. Their 13 HP model was particularly prized by small sawmill operators because it delivered consistent power without the temperamental nature of some competitor engines. NTHE Port Huron Engine and Thresher Company, hailing from Port Huron, Michigan, built their reputation on creating sawmills that could withstand the grueling demands of daily timber processing. Their 1903 model represents the golden age of American sawmill design, a period when manufacturers were perfecting the balance between power, precision, and durability. This wasn't just a machine. It was an investment that could serve multiple generations of a family business. Let's talk about how these two pieces of equipment work together in perfect mechanical harmony. The Reeves engine serves as the powerhouse, its heavy flywheel storing momentum and smoothing out the power delivery. You'll notice that distinctive rhythmic sound. That's the engine's hit-and-miss governing system at work. Unlike modern engines that run continuously, these old-timers only fire when they need to maintain speed, creating that characteristic pop-pop, pause-pop cadence that old-timers remember from their childhood on the farm. NTHE power transfer from engine to sawmill happens through a series of leather belts. And here's where the real craftsmanship comes in. The main drive belt, often 12 to 16 inches wide, runs from the engine's flywheel to the sawmill's main pulley. Getting the tension just right is an art form. Too loose, and the belt slips, wasting power and potentially stalling mid-cut. Too tight, and you're putting unnecessary strain on bearings and shafts, shortening their service life. The operators at these demonstrations have spent years perfecting this balance, and you can see it in how smoothly the whole operation runs. NTHE Port Huron sawmill itself is a marvel of mechanical simplicity and effectiveness. The blade, typically ranging from 48 to 56 inches in diameter, is mounted on a mandrel supported by heavy Babbitt bearings. These bearings, made from a soft metal alloy, were the standard before modern roller bearings, and when properly maintained with regular lubrication, they could run smoothly for decades. The saw blade advances through the log on a carriage system that rides on iron rails, with the operator controlling the feed rate using a hand-operated friction clutch mechanism. What's fascinating about watching this rig in action is seeing the problem-solving that went into its design. Notice how the log carriage features dogs, those sharp, adjustable clamps that grip the log securely. The operator positions these carefully, accounting for any curve or irregularity in the timber. It's not just about clamping down hard. It's about understanding wood grain, anticipating how the log will respond as the blade enters, and making micro-adjustments that prevent binding or dangerous kickback. NTHE actual cutting process reveals the physics and craftsmanship behind sawmilling. As the blade enters the log, you're not just watching steel cut through wood, you're witnessing a carefully orchestrated dance of speed, pressure, and timing. The blade's teeth, hand-filed and set to precise specifications, each remove a small chip of wood with every pass. The kerf, that's the width of the cut, is deliberately wider than the blade's body, preventing the saw from binding as it travels through the timber. Experienced sawyers can tell you stories about reading the sawdust itself. Fine dust might indicate a dull blade, while chips that are too large suggest improper set on the teeth. Here's something that might surprise younger viewers. These old sawmills could compete with modern portable mills in terms of lumber quality, if not speed. The slower feed rate actually produces smoother cuts with less tear out, especially in figured or knotty wood. Many fine furniture makers and restoration carpenters specifically seek out lumber that's been cut on vintage equipment because of its superior surface quality. NTHE operators you see here at Lathrop aren't just running equipment, they're practicing skills passed down through generations. Starting the Reeves engine requires understanding its personality, priming the cylinder with just the right amount of fuel, positioning the flywheel at the optimal compression point, and giving it that authoritative spin that brings those pistons to life. It's a ritual that connects these modern demonstrators to the countless sawmill operators who performed the same motions 100 years ago, from the pine forests of Michigan to the hardwood stands of Appalachia. Nate, the considerations were quite different in 1903. But today's operators incorporate modern safety awareness while maintaining period authenticity. You'll notice they keep proper distance from the blade, maintain awareness of belt positions, and ensure bystanders stay clear of the operation. Back in the sawmill's working days, accidents were unfortunately common, which led to the development of many safety innovations we now take for granted in industrial equipment. NTHE exhibition at Lathrop serves an important purpose beyond nostalgia. It's preserving practical knowledge that's rapidly disappearing. Young engineers and machinists who visit these shows often express amazement at the elegant simplicity of the mechanical solutions. There are no computer chips here, no electronic controls, just thoughtfully designed mechanisms that accomplish complex tasks through leverage, momentum, and precision manufacturing. When these engines and sawmills were built, American industry was transitioning from water and steam power to internal combustion, and the engineering innovations of this period laid groundwork for everything that followed. NTHE community aspect of these demonstrations shouldn't be overlooked either. The volunteers who maintain and operate this equipment form a brotherhood of preservationists, spending countless hours sourcing parts, fabricating replacements for components that no longer exist commercially, and teaching others the skills needed to keep this history alive. Their dedication ensures that future generations can see, hear, and smell what it was like when America's forests were transformed into the lumber that built our towns and cities. Deep in Lunenburg County, Nova Scotia, the Ivan Corkum family operates something truly special, a water-powered sawmill that represents centuries of traditional lumber processing techniques. This isn't a museum piece sitting idle. It's a working operation that still produces quality lumber using methods that date back to the earliest days of North American settlement. What makes this mill particularly remarkable is that virtually every component, from the waterwheel to the carriage system, was hand-built from local timber, creating a sawmill that's quite literally built by and from the forest it serves. Let's start with the power source, the waterwheel that makes everything possible. The Corkum mill utilizes an overshot waterwheel, meaning water enters at the top and its weight, combined with the momentum of the falling water, turns the wheel. This design is more efficient than undershot wheels, where water simply pushes against paddles at the bottom. The Corkum's wheel measures approximately 16 feet in diameter, constructed from locally harvested hardwood, with hand-forged iron reinforcements at critical stress points. The buckets that catch and hold the water are precisely angled to maximize power extraction from every gallon that flows through the system. NTHE mill pond upstream serves multiple crucial functions. First, it provides consistent water storage, ensuring the mill can operate even during dry spells. Second, it acts as a settling basin, where silt and debris drop out before water enters the flume. This is critical because sediment in the water system can cause premature wear on the wheel bearings and mechanisms. The pond also serves as a log sorting and storage area, keeping timber wet and preventing checking or splitting before processing. Water reaches the wheel through a wooden flume system, essentially an elevated aqueduct that channels flow from the pond's spillway. The Corkums maintain this flume meticulously because any leaks reduce power delivery to the wheel. The flume includes a gate system that allows the operator to control water flow, effectively functioning as a throttle for the entire mill. Open the gate fully, and the wheel spins at maximum speed. Close it partially, and operations slow down. This simple but effective control system allows the sawyer to match cutting speed to the hardness and size of the timber being processed. NTHE primary timber species processed here include eastern white pine, red spruce, hemlock, and various hardwoods like sugar maple and yellow birch. Each species presents unique challenges and characteristics. The white pine, for instance, is relatively soft and cuts easily, but requires a sharp blade to prevent fuzzing on the surface. Spruce is harder and contains more resin, which can build up on the blade and must be cleaned regularly. Hardwoods like maple demand slower feed rates and generate considerably more heat during cutting, requiring careful attention to prevent blade warping. And inside the mill building itself, constructed from lumber processed on site, the mechanical systems showcase remarkable ingenuity. The water wheel's rotation transfers power through a main shaft that runs the length of the building, supported every 8 to 10 feet by pillow block bearings carved from dense hardwood and lined with leather for lubrication. This main shaft spins constantly whenever the wheel is turning, serving as the mill's power distribution system. Various machines connect to this shaft through clutch mechanisms and belt drives, allowing individual operations to be engaged or disengaged as needed, and call Joe in. The sawmill carriage represents the mill's most sophisticated piece of equipment. This massive framework rides on wooden rails and carries logs through the cutting operation. The carriage itself is built almost entirely from hardwood, primarily oak and maple, chosen for their ability to withstand constant vibration and impact. The track system uses locally forged iron rails set into wooden ties, with the carriage running on wooden wheels reinforced with iron bands. This might seem primitive compared to modern steel roller systems, but it's actually remarkably effective and much easier to maintain and repair with basic tools and materials available on site. NTHE log dogs. Those intimidating clamps that secure timber to the carriage are hand-forged from iron and designed to penetrate bark and sapwood without damaging the valuable inner wood. Positioning these correctly requires experience and judgment. The sawyer must account for natural log taper, curves, and irregularities, ensuring the first cut produces a flat reference surface for subsequent passes. NTHE saw blade itself, typically 52 to 56 inches in diameter, is perhaps the most critical component. Unlike modern carbide-tipped blades, these traditional carbon steel blades require regular maintenance. The Corkums sharpen and set their blades frequently, sometimes daily during heavy production periods. Blade tensioning is an art form. The blade must have proper tension to run true at operating speed, but not so much tension that it becomes brittle or prone to cracking. Experienced sawyers can tell if a blade is properly tensioned just by listening to its sound during operation. End power transfer from the main shaft to the saw mandrel happens through a series of wooden pulleys and leather belts. The Corkums craft their pulleys from laminated hardwood, building them up in layers for strength and balance. The crown, a slight bulge at the pulley's center, keeps the belt tracking properly without guides or flanges. It's a brilliant passive solution to a complex problem. NTHE mill's capacity depends on several factors: water availability, timber species, and desired output dimensions. During optimal conditions with good water flow, the Corkums can process several thousand board feet per day. That might not match the production of a modern industrial mill, but the quality is exceptional, and the sustainability of the operation is remarkable. No fossil fuels, no electrical consumption, just renewable water power and human skill. The environmental considerations inherent in this operation are worth noting. The waterwheel returns all water to the stream virtually unchanged. No contamination, no temperature increase. Sawdust and bark waste are used for mulch, animal bedding, or composting. Nothing goes to waste, and the mill's carbon footprint is essentially zero beyond the initial construction and blade production. NTHE knowledge required to operate this mill successfully encompasses multiple traditional trades: millwright skills for maintaining and adjusting machinery, blacksmithing for fabricating and repairing metal components, carpentry for building and maintaining wooden structures and mechanisms, and forestry knowledge for selecting and harvesting appropriate timber. The Corkum family embodies this integrated skill set, having accumulated knowledge across generations of operation. Here we have a beautiful example of Depression-era American sawmilling technology. A Frick 00 sawmill powered by an International UD14A diesel engine, currently being set up to cut 2x6 white pine lumber at 18-foot lengths. This combination represents the transition period when sawmill operators were moving away from steam power toward more convenient and economical diesel engines, particularly during the 1930s and 1940s. NTHE Frick 00 holds a special place in sawmilling history. Manufactured by the Frick Company of Waynesboro, Pennsylvania, these mills were known for their compact size and remarkable durability. The 00 designation indicates this is the smallest model in Frick's sawmill line, but don't let that fool you. These machines were workhorses capable of handling substantial timber and producing thousands of board feet per day in experienced hands. NTHE International Harvester UD14A diesel engine powering this operation deserves particular attention. International produced these industrial diesels specifically for stationary applications like sawmills, irrigation pumps, and generators. The UD14A generates approximately 14 brake horsepower at its rated speed, providing consistent power without the fuel consumption and maintenance demands of gasoline engines. These engines were famous for their reliability and longevity. Many are still running after 80 or 90 years of service. NTHE coupling between engine and sawmill happens through a flat belt drive system. You'll notice the operator checking belt tension carefully before starting operations. The belt runs from the engine's flywheel pulley to the sawmill's main drive wheel, and proper tension is absolutely critical for both power transfer efficiency and safety. Too much slack, and the belt can slip or even jump off the pulley during cutting operations. NFOR, today's production run of 2x6 white pine at 18 feet, the setup requires careful calculation and preparation. White pine is relatively soft and forgiving to cut, but producing dimensional lumber demands precision. The sawyer has set the carriage stops and measuring system to yield consistent 18-foot lengths, with the blade height adjusted to produce the 5.5-inch actual dimension that becomes a nominal 2x6 after planing and drying. NTHE cutting sequence for this operation follows a time-tested pattern. The operator first creates a flat reference surface by removing the rounded outside of the log, called a slab. This slab, while not suitable for dimensional lumber, has value for rustic siding or can be processed into chips. With one flat side established, the log is rotated 90 degrees and a second slab is removed, creating two perpendicular flat surfaces. From this point, the sawyer systematically works through the log, producing 2x6 boards with remarkable consistency. What makes this vintage equipment still viable for small-scale operations is the quality of lumber it produces. The slower feed rate and rigid construction result in remarkably straight, smooth cuts. Modern high-speed mills certainly produce more board feet per hour, but they can't match the precision and surface quality of a properly maintained and skillfully operated frick mill.